Hello and welcome to the second video in my series about technical inspection, or TI, of the M1 Garand rifle. Today we're going to talk about the bolt assembly. In my first video, I described the process for TI of the M1 Garand receiver. Stick around, this will be fun and educational. This video series is intended for individuals that are building an M1 rifle, but the TI of the various parts applies to all rifles. It is easy to buy Garand parts. They're everywhere. No doubt you have seen every single part from receivers to end block clips for sale at gun shows, online, and at gun stores. It's a buyer beware world out there. Millions of Garands were produced between the late 1930s and the mid 1960s by the U.S. government and other countries. Many guns were given to foreign countries as defense cooperative items. Commercially produced M1s are also available, as are any number of re-welded receiver guns. With all the parts around, M1 enthusiasts and shooters should be aware of the technical standards that were established by the United States military in order to ensure safe and reliable function of these rifles. As for M1 bolts, I see them for sale all the time. Often, they're being sold according to manufacturer and/or period in which they are manufactured. World War II era Winchester bolts sell for a premium for those folks who are assembling a gun to have all correct World War II parts and manufacture. Those details, however, tell you nothing about the serviceability or safety of a part. I suppose if you never intend to fire your rifle, serviceability and safety means very little. If your rifle is capable of firing, though, it's always advisable to have safe parts. The TI process is designed for armorers responsible for the readiness of their unit's small arms. The criteria I will present here is from that perspective. I encourage everyone who knows enough about M1s to assemble them into working rifles to know what constitutes acceptable, unacceptable, and superior when it comes to their rifle's parts and systems. There are numerous sources of information, but I sincerely recommend the shop manuals by Jerry Kuhnhausen. They are available online. If it is at all possible and within your budget, you should start with a new bolt. There are still a number of new old stock or NOS bolts and bolt assemblies available. Over the years, thousands of these bolts have been sold at surplus. If you cannot or do not wish to start with an NOS bolt, then you should take the time to ensure your bolt is safe and reliable. So let's start with a complete assembled bolt. You will commonly find assembled bolts in your search for bolts. However, assembled bolts are not a deterrent to quick visual inspection of the bolt. The bolt body itself is the most important part. You can have brand new parts on a bolt assembly that is still unacceptable. In this case, you may wind up with $20 or $30 worth of usable parts and a bolt body that will make a piss poor paperweight. Any signs of cracks or welds are a no-brainer. Discard with a smile, move on to the next seller. First and foremost, you're concerned with the bolt face. Bolt faces wear much faster than the other surfaces of the bolt body and are commonly available in unserviceable condition. You want a bolt that has zero wear on the bolt face. The most common wear on the bolt face is that from primer leakage, causing a ring on the bolt face around the firing pin hole. These rings are caused by primer leakage, usually from corrosive, heavy mercury primers, and not being cleaned quickly enough. If you see a ring, however, don't despair right away. Check to see if there is a difference in the surface of the bolt face. I normally accomplish this delicate task with my specially calibrated armorer's fingernail assembly. If you feel a difference in the surface with your fingernail, it probably means that you have 5 to 10 thousandths of an inch of difference, and you should probably skip that bolt unless you are looking for a piss poor paperweight. The bolt face should not be uneven or pitted. Rust pitting on the bolt face is a no-go. If there's rust pitting on the bolt face, there's no way to tell how much damage has been done internally to the firing pin tunnel and the extractor and ejector spring and detent holes. The other thing you should look closely at after searching for a ring on the bolt face is whether the firing pin hole is out of round or oversized. Oblong holes are a no-go. Trust your eyes. Oblong holes in private pocket rings are common neighbors on worn-out bolt faces. If you want to gauge the size of the hole, or your calibrated armorer's eyeball assembly is a little fuzzy, you can use a number 45 drill bit shank as a maximum receiver gauge. If it drops right in or rattles around, you know your firing pin hole is oversized and unacceptable. If it isn't, then move on to your next inspection. The bolt must lock into the lugs in the receiver in order to provide a safe, locked platform for igniting the primer. So obviously, you want to closely inspect the locking lugs and the op rod lug. This is one time when looking at a used bolt can be very helpful. The parts of a used bolt, provided it has not been refinished, will be shiny and obvious to the eye in those areas that you want to pay the most attention to. Obviously, these are surfaces that receive the most mechanical contact. You do not want a bolt that appears overly worn, battered, mushroomed, pitted, or cracked. These shiny surfaces can help to guide your eyeball assembly gauge to those attention areas. Bear in mind that if an M1 rifle fires out a battery, which happens for a number of reasons, the rear side of the locking lugs will impact the receiver in the wrong place and will bear marks because of it. Such bolts have been exposed to improper levels of pressure and should be discarded. At the rear of the bolt is the hammer cocking surface. As the bolt travels to the rear in the unlocked extracting and cocking process, this surface contacts the hammer and pushes it backwards into the cocked position. You will seldom encounter a bolt damaged in this area, but because it is a high contact camming surface, you should ensure it is in good shape. The same applies to the top rear surface of the bolt body. It can be shiny, but it should not be battered, pitted, or cracked. If it is, don't use it. If you start with an assembled bolt, you can also do a couple of small checks. First, move the firing pin back and forth in its channel. How does it feel? Does it stick? Is it sluggish? Gritty? When you push on the firing pin, do you see it protrude in the bolt face? Just for the record, this is a good thing to gauge as well. Minimum firing pin protrusion for TI is 0.044 inches, and maximum protrusion is 0.060 inches. There are gauges for sale, or if you have the equipment you can make one. Old U.S. government gauges are simply a flat bar of steel with the minimum and maximum distances machined into each end, and they would fit right over the firing pin hole into the bolt face. You can also point the bolt face up, hold the firing pin down, and shake it. If you hear something rattling when you're holding the firing pin down, there's a very good chance you have a broken firing pin and you're hearing the parts rattling around inside. You can also use your calibrated armorer's fingernail assembly to push on the extractor and the ejector, and you should feel good spring tension against them. If they return slower than your finger, they may be rusty or filled with dried grease. Okay, well that's about all you can do with an assembled bolt, so let's take it apart. I sincerely recommend spending $40 when buying a bolt disassembly tool. Really, the bolt can be disassembled and assembled without one. Just be prepared to launch your ejector into low Earth orbit or into your calibrated eyeball assembly at Mach speed. If you must challenge the not necessarily almighty gods of ejector spring tension, please wear safety glasses. For the record, the odds are against you, and I speak from experience. Disassembly tools, like this one, can be purchased online at Brownells, Midways, eBay, etc. Or maybe you can pick one up at your local gun shop or gun show. Make sure your tool has the pin in the rear hole for the M1 bolt. The front hole is for the M14 or the M1A bolt assembly, which is slightly shorter. By the way, with the exception of the roller on the op rod assembly, or the op rod lug of the bolt, everything that I'm covering here applies to both the M14 M1A bolt and the M1 Garand bolt. So you can place your bolt in the tool just like this, making sure that you line up your ejector pin with the pin in the front of the receiver, or in the front of the tool. Slowly push down on the lever and compress the ejector and spring, and then push up to release the ejector, or excuse me, to release the extractor, and then slowly release the tension So at this point what you have is extractor is removed from the bolt. You want to take a good look at it, make sure it's not cracked. Once you've done that, you can remove the ejector, plunger, and spring assembly. You can see this one has got a lot of dried ancient cosmoline and oil and grease and gunk in it. And you can do the same with the ejector spring. Check these parts for cleanliness and rust. New old stock bolt assemblies and used bolts will probably be dirty inside these holes. I recommend cleaning them out with some lightweight oil and a pipe cleaner or 2 or 3. So that's about it for inspecting the M1 bolt. The firing pin, the ejector, the extractor, the springs are all parts that can be purchased new and replaced. There are TIs for these parts as well, especially the firing pin. But frankly, going into all that right now makes me want to gouge my eyes out. If you really want me to, I'll do a video for TIing M1 firing pins. Just let me know below in the comments. If you like this video, found it helpful, please hit the like button. If you want to keep up with this series of videos on technical inspection of the M1 Garand, please subscribe below. Thanks for taking the time to spend with me. God bless America.